GitHub. In this class, I'm going to explain about that operation of the linear probing. So my first operation is that insert function. I'm going to explain that insert operation. How will you going to insert the element using the pseudocode? So this is my given table. My table size is 10, and I'm going to insert 41, 50, and 60 in my table using this pseudocode. So I have created one method, is that insert method. In that method, first I pass that 41. First I pass 41, then I'll do what? 41 modulus table size. If I do the 41 modulus table size, my table size is 10. So 41 modulus table size I do, then I'll got that index value is 1. Now I'll check that is hash table of index 1 equal to null, means that is my first index is free. This is nothing but it's checking that is my first index is free. So yes, this is free. Then what will you do? You have to store hash table of hk, means first index, equal to 41. So this 41 is going to store at first index. It's not going to go any else part, because in the if condition this check that this 41 getting that place that's empty, and there this 41 is going to stored. Now the next element is that 50. Now next element is 50. Then again, now instead of 41, I'll pass the 50. I'll pass the 50. So 50 came here, 50 came here. Now calculate the index of the 50. If you are going to calculate the index of the 50, you got 0. So now check that hash table of 0th index equal to null. No, this is not null. This is already 70 just stored there. So don't go this value, directly come to the else part. In else part, what will you do? Check that I equal to 1. If I equal to 1, and I less than table size. Table size is what? Table size is 9. So 1 is less than 9. Yes, condition true. Then come to the here, calculate the index using linear probing. Calculate the index using linear probing. So linear probing, hk is what? Hk value just now you calculated, that is 0. 0 plus I value is 1. So 0 plus 1 modulus table size. Table size is 10. So 1 modulus table size, you will do that, you will get that index is what? 1. Now check that the first index is equal to null, means each first index is empty. No, this is not empty. Then what will you do? No need to run this, no need to run this part, no need to run this. And then increment the I value, increment the I value. Now I become 2. Now I became 2, and h of k is what? H of k value is 0. So 0 plus 2 modulus table size. So 2 modulus 10, you will get the 2. Now check that hash table of 2 index equal to null. No, second index is also not free. So don't store the value. Then I will going to increment by 3. So 3 modulus 0 plus 3 modulus table size. So you will get that index value is what? 3. You will get that index value is 3. Now check that this condition, we are going to check that is h of k third index equal to null. No, that is also filled. So don't execute. Now increment the I value. I become now 4. So h of k value is what? 0 plus 4 modulus table size, means 4 modulus 10. You will get that fourth index. Now you check that h of table fourth index equal to null. Yes, fourth index is null. So 50 is going to store at what? 50 is going to store at fourth index. Like that you can do for the 60 also. Similar like that, if it is all this table is filled, suppose this table is filled, fifth index is suppose 7 is there, 9 is there, and 10 is there, and 11 is there, and 12 is there, right? Now the my next element came like suppose my next element is 70. Now my next element is 70. I'm going to store 70 in this table. Not 70, I'll take 18, this better. So if I'm going to take 18, I'm going to store 18 in this table. So first I'll call here, instead of 50 I'll pass that 80. So I'm going to pass here 18. If I pass, then I'll come here, I'll calculate the index of the 18. We'll get that index value is 8. We'll get the index value is 8. Then we'll check that hash table of index 8. Hash table of index is 8. Is it free? No, it's not free. Then come to the else part. Come to the else part. Now check I equal to 1 and I less than table size 9. Yes, condition true. Then come here. Now h of k value is what? 8. 8 plus I is 1. 9. 9 modulus table size. 9 modulus table size. Table size is what? 10. So 9 modulus table size you do that it become 9. So 9 check that has to table 9 equal to null. No, ninth index is also not free. Then what will you do? Increment I value. Increment I value. I become 2. Then uh, then 8 plus 2, 10. 10 modulus table size 0. Then check that 0th index, is it free? Not free. Then similar like you check that 1, 2, 3, 4 like that. You come to the 8 and out of that this for loop is going to complete it. Means it will run till order of n time. It will run till order of n time and then this loop is then loop will fail, condition will fail because that there is no place. Then you come here, you check that is I equal to table size, is I value equal to table size and table size is what? 10. Is I equal to 10? Yes, I equal to 10. Then you can say that my table is full. I am unable to store the 18 value because my table is completely full. So this is the all about the insertion method. Now I'll explain about the searching method. Same type, the same insertion method is similar like that. Searching method is also similar like the insertion method. Same procedure. Here I'm going to check that is 50 there in my hash table or not. So for that I'm going to pass 50 in the search method. If I pass 50 to the search method, I'll come here, I'll calculate the index of the 50. So 50 modulus table size is 10. I'll get the index 0. Now we'll check that hash of 0th index equal to 50. Go check that is it equal to 50. No, it's not equal to. Then come to the else part. Now come to the else part. Then what will you do? I value is equal to 1. Table size is 10. Is I less than table size? Yes, condition true. Now check that h of k is what? 0. 0 plus 1. 1 of modulus table size equal to in 1 value. Now check that hash table of first index equal to 50. No, this is 41. It's not equal to 50. Then don't execute this part. Now increment the I value. Now I become 2. Now I become 2. 2 less than table size. Yes, condition true. Come here. Now h of k value is 0. 0 modulus 0 plus 2 modulus table size means 2 modulus 10. What value will get? That 2. Now check that is second index equal to second index value. H of k index value means second index value equal to 50. No, this is not true. Then I will increment it by 3. So now I become 3. And h of k value is 0. So 0 plus 3 modulus table size means 3 modulus 10. You will get the third index. Now check that is third index equal to 50. No, this is not 50. Then again what will you do? Don't execute this part. Now I become 4. Now I become 4. So now here h of k value is 0. 0 plus I. 0 plus 4 modulus 10. So what will you get? That 4 modulus 10 equal to 4. Go and check that h of 4 means hash table of 4th index. H of table of 4th index is equal to 50. Yes, equal to 50. Then you say that the found at index. Index value is what? Index is what? Is nothing but a 4 value, that is going to print the index. This will going to print the index. This is going to print the index value. Okay, now I am going to search the 45. So for 45 what happened? For the 45 what will you do? You will going to continuously you will going to check that and at last you will not going to get whenever the space comes there is nothing is here, then it will check that is I equal to table size. Yes, you can say that it's equal to table size and then you can say that the element is not there, right? The element is not there. That's the searching method. Now coming to the deletion method, and this is the deletion is the difficult in the linear probing. Reason is that I am going to explain in this program. So in deletion method, suppose I am going to delete the 50. Suppose I am going to delete the 50. Now what will I do? I will pass here 50. I pass here 50. Then what I am doing here, I'll calculate the index of the 50. So I got that 0 index, right? I got the index 0. Now I'll check that is 50 is there at 0th index. No, here I have given that if hash table of key equal to 50. Key value is what? H of key value is what? 0. H of key value equal to 0. So hash table of 0th index equal to 50. No, it's not equal. Then what will you do? Don't execute this part. Come to the else part. Come to the else part. I value is 1. I less than table size. Yes, condition true. Then come to here. Index equal to h of key plus I modulus table size. So now index value is what? Now index value is what? 0 plus 1 modulus table size means index now 1. Now check that has table of index equal to 50 means first index is also containing 50. No, this is also not containing. So don't execute this one and increment the I value. Now I became 2. So 0 plus 2 modulus table size means 2 modulus 10. If you do, you got second index. So here hash table of index, hash table of second index is equal to 50. No, this is not equal to 50. Then increment I value. I became now 3. 3 plus 0 plus 3 modulus table size if you do, you got 3. Go and check the third index. Is third index containing 50? No, this is also not containing. Then I going to increment by I is going to increment by 4. So 0 plus 4 modulus table size if you do, you got fourth index. Index is 4. Now check that hash table of fourth index equal to value. A value is what? 50. Is it 50? Yes, condition true. Then what will you do here? Hash table of index. Index is what? 4 equal to null. What will you do? Don't simply free that memory. Here you have to give something like that. There is some value there. There is some value earlier there. You simply swapped it. You are not completely free. That is the solution of linear probing. If you are going to completely remove, this will going to generate the problem in the searching. So for that reason, what I am doing at that place, 50 I am removing and putting what? Null I am putting that. So it is going to help to in the search. Now I got the 50, I'll break it. Because I say that I got my value 50. Here I'll say that deleted from the hash table value is 50. That I'll message it and break it because I am searching 50. Right? And if I am going to if I am going to delete some element that is not there, that will come here and it will check that I equal to table size. If it is equal to, then they will say that the deletion is not possible because the element is not there. That's all about the operation of the linear probing. Thank you for watching my video.